Welcome to By Excellence Tutorials. And in this video, we are going to do dimension analysis to derive formula. Okay, mind you, dimension analysis can be used to derive formulas or to prove if the formula or the expression is consistent in terms of dimensions. So the centripetal force F acting on a particle moving uniformly in a circle depends on the mass of the particle M, the velocity of the particle V, and the radius of the circle R. Use dimensional analysis to derive the formula for centripetal force. So before we start, we know, if you don't know, centripetal force is given by mv squared R. Okay, that's the centripetal force. So now we're going to see if we are going to use dimension analysis, and it's going to give us this. Okay, so now what we do, so the first we write the expression, the variation, and we are taught to say force is varying, okay, depends on the mass, the velocity, and the radius R, like that. So we don't know if these factors M, V, and R, they have certain indices. Okay, they have certain powers, or they have certain, these variables have got certain coefficients. So we are going to have force being equal to, once we introduce the equal sign under variation, we're going to introduce K, and this K is a dimensionless constant, and we're going to have M, X, V, Y, and R, Z. So you can use any variable, any, even A, B, or C, and then we're going to work on finding the values of those variables X, Y, and Z. So how do we do that? We first have to find the dimensions. Now, the dimension of force, we know that force is given by mass times acceleration, and mass is given in kilogram, and acceleration is given in meter per second. So the dimensions of force, we're going to have M, L, T negative. Okay, that's acceleration is the power 2. So we have a negative 2 there. Okay, so we have a negative 2 up there. So those are the dimensions of force. Now, the dimensions of mass is basically M. The dimensions of velocity, the velocity is given that, and the dimensions are going to be LT inverse. And then we also have what? R. So R is basically the length. So the dimension is going to be L. So now we can substitute these dimensions in that equation. So we write this equation in terms of dimension. We are going to have M, LT negative 2 being equal to mx. So K is a dimensionless constant, doesn't have dimensions. I mentioned that. And our V is going to be L to negative 1, everything to the power Y. And then we have L to the power Z. Okay, so we can distribute the power there. So we are going to have T and X, L power Y, and T to the power negative Y, and we have Z there. Okay, so now, according to indices, we have same bases, L and L, but different powers. So what do we do? If we have same bases multiplying each other, we can add the powers. So we are going to have m to the power x, l, y plus z, and t negative y, like that. So we can equate the powers now. We can equate the powers where we have same bases, m and m, we have to equate their powers. L and L, we equate their powers. So here we have 1 and here we have 1. So we have for m, we are going to have 1 equal to x, or x equal to 1. And then for L, we have 1 being equal to y plus z. So we have 2 unknowns. So we can jump to the third one. And t, we have -2 equal to negative y. So y is equal to 2, because the negative and negative will cancel. So we can substitute y into this equation here, where we have 1 equal to 2 plus z, and z is going to be equal to -1. So these are the values now of x, y, and z. So x is equal to 1, y is equal to 2, and z is equal to -1. So we substitute these values into that equation where we have the equation, which is this one, mx vy rz. So force is going to be equal to k, and mx is equal to 1, vy is equal to 2, and then z is equal to -1. Okay, so this is how the equation is going to look like. And then we have force is equal to k, m to the power 1 is m, and v squared. And then this is inverse. So r inverse is same as 1 over r. So we have over r. So we have derived the centripetal force using dimensional analysis. Okay, so if you have found this video to be helpful, kindly subscribe to the YouTube channel if you have not subscribed yet, and click on the notification bell so that you get notified each time I upload a new video. And you can share, like, and comment on this video.